Welcome AP. We have 16.5. We're going to start with strong acids and bases. Okay, so we have two learning objectives in the AP video 8.2 regarding strong acids and bases. Take a minute to read the two learning objectives, what AP expects you to master. Come back to me after you've made some notes and annotate. Strong acids and strong bases. Back in chapter 4, we learned that strong acids, strong bases, when it comes to strong electrolytes, completely 100% dissociate. That acid, it hits water and it's going to break up into its ions and no more acid. Okay, there are 7 strong acids that we need to know. Okay, 3 of them are very easy because 3 of them come from halogens. Okay, so if you notice on the periodic table with the halogens, you got chlorine, bromine, and iodine, but not fluorine. Fluorine is not a strong acid. Okay, so these 3 are strong acids. The rest of them are polyatomics. You're going to find in the video, the very last video, which I want to say it's 16.10, the more oxygens, the more acidic it is. And notice there's a 3, 3, 4, and 4. Now, I can't say that for every acid, but notice there's a lot of oxygens in these 4. So we have nitric acid, we have chloric, perchloric, and then sulfuric. Okay, so we need to know these 7. When you write a strong acid, 1 arrow in your balance equation. Now, I don't like to put water in my equation. I prefer to write it like this, how it dissociates into the ions. The only difference is if AP wants you to solve for hydronium, then you have to add the water to the balance equation. Either way, the math works the same way. Just remember that H and hydronium, they're interchangeable. Okay, so it doesn't matter which one, but if you have to solve for hydronium, you got to add the water to your equation. The bases are even easier than the strong acids because with the strong bases, there are 8 of them. You got to know the 8. You have the alkali metals, which is group 1. And you have lithium, sodium, potassium, rubidium, and cesium. All of them in group 1. Okay, obviously not francium. Francium is nuclear. Okay, we're not talking about nuclear. And the heavier elements in group 2. So notice in group 2 you have, what is it, beryllium, magnesium, you got calcium, strontium, and barium. It's the last 3. The last 3 in group 2. Strong electrolytes completely dissociate. Okay, 1 arrow, just like strong acids. And don't ever put water as a reactant for bases. Okay, don't ever. Because what happens is it's like double replacement. You're going to get the exact same thing. So with the strong base, completely dissociates, and the 2 ions. Be very careful when it comes to the last 3, because these last 3, these are group 2. And remember, they have +2 charges. So you actually, what happens is, so if it was like calcium hydroxide, which I think we're going to do a practice problem of it, breaks down into calcium, but you have 2 hydroxides. There's no diatomic hydroxide, so that 2 comes in front, which means you have twice the moles, twice the concentration compared to calcium. Okay, so you have a 1 to 2 relationship. So be very careful of those subscripts. So let's practice. Let's get those calculators out. Let's check those answers. Keeping track of that temperature. We got that temperature still at room temperature. If I'm given this acid, and HCl is a strong acid concentration, what is the pH and the pOH? Okay. Well, we have equations that we know that are on our AP equation sheet. Now, because I have an acid, I'm going to go to pH first. And then I'm going to take my pH, and then I'll go to pOH. Okay? So how can I get to pH? Well, first we need an equation. So the negative log of the H concentration. Well, where's the H concentration? So first, let's write a dissociation equation. Now, like I said, I don't ever really put water in my equations unless I have to. So I'm going to get a 1-to-1 ratio. So aqueous and aqueous. And because this concentration was 0.0025, and because I have a coefficient of 1 and 1 and 1, all of these concentrations are all the same because it completely dissociates, okay? So because they have the same moles, they have the same concentration, okay? So I know the concentration of this acid, this H+, so I'm going to take the negative log 0.0025. Now remember, we have brackets, so there's no need to put molarity. And pH doesn't even have units to begin with, okay? So negative log of 0.0025. And with 2 sig figs, we're going to get a pH of about 2.6. Now, does this make sense? Well, the pH is less than 7. We know this is acidic. And why? Because we're starting with a strong acid. Okay, so this pH better be less than 7. And to get to pOH, I have an equation. As long as temperature is 25 degrees Celsius, I can add this to 14.0. So because I have a number after the decimal, I'm going to put 14.0 instead of just 14.0. Because adding, subtracting sig figs, the least after the decimal. And this is where sig figs get a little wonky. So I have 2.6 is my pH, so basically subtracting. 14 minus that 2.6, 1 after the decimal, and I'm going to get my pOH is going to be 11.4. And remember, these two added together should equal that 14. Okay, let's try a base. Sodium hydroxide, strong base. So my sodium hydroxide, as we did the equation above, 1-to-1 relationship. I'm going to get my sodium, and then I'm going to get my polyatomic hydroxide. I want to do the same thing. I want to find pH and pOH, but who do I have to solve for first? Since I have a base, I have to solve for pOH first. And then I could take a field trip and subtract 14 to get to pH. So this pOH, same thing as up there. And make sure your P is a little small. You don't want it to look like phosphorus. So I'm going to take the negative log of my OH. Now remember, because this is all a 1-to-1-to-1 relationship, this concentration equals all of the ions. So that negative log of 0.028. So let's plug that in. We're at negative log of 0.028. And with 2 sig figs, I'm going to get 1.6. Okay? So now, if I take my pH plus pOH equals 14, I'm going to take that 14 and I'm going to subtract it by that 1.6. And because I have a number after the decimal, I'm going to put 0.0. So my pH is 12.4. And does that make sense? Well, yes. Since my pH is greater than 7, I know this is a basic solution, and it should make sense because we have a strong base. Okay, so remember, with strong acids and strong bases, your pHs are very low or very high, depending on what it is. So what if you have that subscript, like we did before? So calcium hydroxide breaks apart into my calcium and my 2 hydroxides. Okay? So if my concentration for this calcium hydroxide is 0.00100, well, it's going to be the same concentration for this calcium because it's a 1-to-1 ratio. But it doesn't equal the same for hydroxide. You're going to have to take 2 to that value, and that's the concentration for that hydroxide. So that looks like 0.0022. That's the value that we need. So we can go to POH and then take a field trip to pH. Okay? So same equations as letter B. So POH, negative log of OH, and negative log of 0.0022. So negative log 0.0022. 2 sig figs, and I'm going to get 2.7. And then I'm going to take my equation and subtract by 14.0. And I'm going to get, what are we solving for? pH. There you go. 11.3. And there it is. Okay? Remember, you have these equations on your equation sheets. Okay? So let it help you. Number 2, we want to find concentration, and we're given pH. Okay? All right. So notice right here, I have KOH, strong base. So KOH breaks down into K and OH. Remember, these are all strong acids and strong bases. So if I know pH, where can pH get me? Okay, well, pH, I can take a field trip to something. I can go to H concentration. And then from H concentration, then I can get to OH. So figure out what map you need to use to get there. So if I need H concentration, what equation do I use? Well, you do have this one. The problem is it's not on your equation sheet. So this equation, not on AP equation sheet. Which means, what's the other way of saying it? You need to learn it. Okay? So 10 to the negative 11.89. So remember, you have this button. That's your anti-log button. So second button, hit your log, and then negative 11.89. And we do have 4 sig figs. So my H concentration, 1.288 times 10 to the negative 2, and then molarity. Could I maybe go to POH and then HOH concentration? Sure. But I always go back to the first equation I taught you in this chapter, KW. Because remember, H plus and OH, H plus times OH minus equals 1.0 times 10 to the negative 14, as long as my temperature is at room temperature, which it is. Okay. Now, because this H plus has 4 sig figs, I need to keep the 4 sig figs going because that's the sig figs that they gave me. So that's why this 1.0 and 14.0, you can add a little bit of zeros if you need to. Keep the sig figs that AP wants. So I'm going to take my 1.00, excuse me, divide by my 1.288 times 10 to the negative 12. And remember, I'm solving for OH. Okay, so don't forget to hit your E button. And I'm going to get 4 sig figs, 7.764 times 10 to the negative 3. There you go. Okay, so I'll fix that up there. I probably went a different direction when I was solving it the first time, but it's okay. We're still good to go. Okay, be careful of those subscripts. So there's that calcium one again. So I'm going to get my calcium plus 2 and my 2 hydroxides. So remember, this is a strong base. And I'm giving you pH. Okay? So with that strong base and pH, same thing. I can go to, if I want, I could go to POH. And then I could go to the OH concentration. In this case, I went from H plus to OH. Either route is fine. So for this pH, I'm even going to do the other version. Or you can go to H plus and then go to that one. Whatever one makes sense to you. I'm going to go the first route because I'm going to take my pH plus POH equals what? Well, equals 14.00. Because my pH has 4 sig figs, I'm going to make it equal 14.00. So my pH is 11.68, solving for my POH. So 14 minus that 11.68. And I'm going to get POH equals 2.32. Okay? And remember, this is adding, subtracting, so my sig figs are looking good. Whoops, I don't want to box that. And now I'm going to go to my OH concentration. And remember, you don't have this equation. This is one of those that you have to know. So 10 to the negative POH. I know my exponent's going to be around 2 or 3. Remember the trick that I taught you? Because of that value right there, it's going to be close to the exponent. So second function, log negative 2.32. And we should get around 4.79 times 10 to the negative 3. And we did solve for molarity. Okay. Now, what if you went the other route? You went to H plus and you went to OH. What happens is it's usually that last digit, it can be off. It can be off by whatever it can be off. That's why I think when I first solved part A right here, I went from POH and then I went to, sorry, taking a field trip there. And then I went to OH, so that's probably why my digit is a little off right there. Okay. Other than that, ladies and gentlemen, that's Strong's. But then we get to crazy, the weak. See you on the next one.